All right, so this is lesson 48, moving on to something called frequency tables. A frequency table is a way that we can represent data in a particular set so that we can see the value of the data and how many times we have that value in the data. So a frequency is the number of times a value of the data occurs. So do we have 5 people with this characteristic? Do we have 10 people? That is the frequency. A frequency table is constructed by arranging the data in order from least to greatest with their corresponding frequencies. And classes are categories into which the data will be grouped. We'll talk about that later. So here we have an example. We want to construct a frequency table for the following data set that represents the number of cups of coffee people drink in a week. So we have all of these numbers. And by themselves, these numbers don't tell us a whole lot, right? It's a little bit overwhelming to just see this list of numbers. So we want to construct a frequency table for it. So in a frequency table, we always have two columns: value, what is the value of the data, and the frequency. How many times is that value taken on? So here I have my least number here is 1, and my greatest number is 10. So remember, this 1 represents that a person drank 1 cup of coffee a week, and this 10 represents that a person drank 10 cups of coffee in 1 week. So the values will be the numbers 1 through 10. Again, this represents how many cups of coffee somebody drinks in a week. 4, 5, 6, 7, 8, 9, 10. And then for frequency, we need to go through the data set and count how many times we have each of these values. So if I go through the data set and I look at how many ones I have, how many people drink 1 cup of coffee, I have 1, 2, 3. So right here, this pair says that 3 people drink 1 cup of coffee. Okay, what about 2? How many people drink 2 cups of coffee? Well, I have 1, 2, 2s. Oops, I need to do it in blue. 2. It looks like I don't have any 3s. That means that nobody drinks 3 cups of coffee. I also don't have any 4s. How many 5s do I have? I have 1, 2, 3, 4, 5, 6. So 6 people drink 5 cups of coffee. Okay. What about 6 cups? I have 1, 2. 2 people drink 6 cups of coffee. Looks like I have 1, 7. No 8s, no 9s, and 1, 10. So this is our frequency table. And a good check is we want the number of numbers we have here to equal the sum of the frequency. So how many people did I survey here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 people. So I surveyed 15 people. That means that I want to make sure that I have 15 as the total for my frequency. And if I add all of this up, 3 plus 2 plus 6 plus 2 plus 1 plus 1, that is equal to 15. So that means that we have accounted for every single person that was surveyed. All right. Next, we are going to go into something else called relative and cumulative frequency. So we have a frequency table here. It doesn't specify what the values mean in this particular situation. But our example says, given the frequency table below, create the corresponding relative frequency table and the cumulative frequency table. We want to round to 3 decimal places. So we have this frequency table here, and the relative frequency, how we calculate this is the frequency divided by the total number. So in order to get this total number, I need to add up all of my frequencies in this table. So 10 plus 3 plus 4 plus 9 plus 6, this is 32. So total, I have surveyed or collected data for 32 people total. So this is my total. So for my relative frequency here, I take the frequency for that value and I divide it by the total number of frequencies that we have. So if I look at the value 3, I take the frequency that corresponds to that value, which is 10, and I divide it by the total number, 32. And if I take 10 and I divide it by 32, this is 0.313. For the value 4, I have frequency 3. I divide that by my total number, 32. And 3 divided by 32 is 0.094. For my value 5, I have frequency 4. I divide that by my total, 4 divided by 32, and this is equal to 0.125. For 6, my frequency is 9. I divide it by the total. 9 divided by 32 is equal to 0.282. And finally, my frequency for 7 is 6. I divide that by 32. This is equal to 0.188. And if we were to add up all of our relative frequencies, they should add to 1, because this is just the parts of the total, right? So this should add to 1. So that is relative frequency. How many times does a certain value occur? And basically what this means right here, this 0.313, that's 31.3%. What this number means is that the value 3 occurs 31.3% of the time in this particular experiment. That's what that number means. All right, moving on to cumulative frequency. What does that mean? Well, here I basically add to the number before. What does that mean? Well, the first value I have here is 3, and my cumulative frequency here is just that number, right? So for over here, for 3, my relative frequency was 10 over 32, which was 0.313. But for the value 4, what I'm going to do is I'm going to take the relative frequency for 3 and add it to the relative frequency for 4. This word cumulative means all together. So I take 0.313, that's the frequency for 3, and I add to it the relative frequency for 4, so plus 0.094, which is equal to, let's see here, 0.406. So that means that 40.6% of the data is accounted for in the values 3 and 4. For 5, I take this number here, 0.406, and I add to it the relative frequency for 5, which was 0.125, and that is equal to 0.532. That means so far 53.2% of the data is accounted for. For 6, I will take this number that I just got, 0.532. I will add the relative frequency for 6, which was 0.282, and that is equal to 0.813. And finally, for 7, I take this 0.813 and I add our relative frequency for 7, and I get 0.188, and this is equal to 1. So what the cumulative frequency means, just maybe I'll write it out here, is that here, 81.3% of the data is accounted for before and at the value 6. So that means that 81.3% of this data has the value 6 or below. That is what cumulative frequency means. Okay, we have another example to show us what this kind of cumulative frequency means. A data set is summarized in the frequency table below. Using the table, determine the number of values greater than or equal to 5. So how many values do I have that are greater than or equal to 5? Well, here are my values, 5, 6, 7. And I want to know how many times these values occur. So I know that 5 occurs twice. I see that 6 occurs 4 times. And I see that 7 occurs 8 times. So this is 14. There are 14 values greater than or equal to 5. It might be easy to say, oh, well, I just have 5, 6, 7, that's 3. And we do have, 3 of these values that are greater than 5, but we need to also consider the frequency. How many times is each one of those values occurring? So we have to take into account the frequency as well. All right, that is lesson 48. We have one more lesson, 49, so I'll see you there.